Morphomatic is a morphing animation modifier for 3ds Max. We'll find it in the modifier panel. By playing back this animation, we can see here all the animated values. The first difference between Morphomatic and the 3ds Max Morpher is its speed. Morphomatic is 3 to 4 times faster than Morpher. Morphomatic allows you to work with progressive morphing, which enables us to obtain nice interpolation at the morph target level. Morphomatic was developed by a team of professional animators to answer their needs and the needs of increasingly complex animations. We will now study in detail all the different morphing options available in Morphomatic, the most evolved tool for morph animation in 3ds Max. To use Morphomatic, it's important to have an object and copies of this object that we deform by simply moving their points. It is very important to never remove or add points so that these objects can work at the morphing level. Here we can see a series of heads, which are copies of the original. Each one is deformed, showing different possibilities for facial expression. We can see it shouting, which deforms the mouth, or expressing emotion by using the eyebrows, or the eyelids, or the lips. Once these morph targets are created, we simply have to select the original head and apply the Morphomatic modifier. We now have several options. The most simple but least advanced is to click on the Load Multiple button in the Global Parameters rollout to be able to choose the list of all the objects we wish to load. Automatically, all the objects that have the same number of points will appear in the list. By using the different spinners, we will be able to deform the face while going from one state to another. Morphomatic also enables us to assign as many morph targets as we wish. A more advanced method is to do it channel by channel by clicking Insert or Pick Targets to choose a target which we wish to load into a channel. If we assign the wrong target, we can click on Remove. The other possibility is to go by groups. Here we'll select the various phonemes for the mouth positions, which will be then loaded onto the modifier. We now select the face expressions. And now the eyebrow movements. By using this method, we establish a certain order in the list. We have loaded one target per channel. We will later see how to apply several morph targets to the same channel in order to create progressive morphing. Many keyframing tools are available in Morph O matic. We will find them within the keyframing rollout. All the options we have here make it possible to create or modify keyframes on the group selected here. By default, we have two groups. All channels represent all the channels in the Morph modifier. Current channel represents the active channel that we select by clicking on the channel button. We will later see how to create new groups in this list and to include the channels of our choice. On the options level, we have the possibility of creating a keyframe on all the channels or only the current channel. Here we could say that we want to create a keyframe on the current channel. The keyframe is created. We can remove this keyframe with the delete button. We also have cut, copy, and paste operations. If the animation director really likes any character's expression, such as for example this one, we could click on copy and then paste the keyframes at any time. This would paste exactly the same values. We can also remove this keyframe at any time to add it elsewhere by using cut and paste. In the same way, if you want to replace an expression with a default face, we can use the makeZero function, which will put a 0 value in all the channels belonging to the selected group. When we are creating keyframes, we can define the type of in and out tangent we wish to use for the animation curve we are creating. This is, of course, if we have a Bezier controller applied to the channel. We can choose among the common tangent types, such as ease in or ease out, smooth or auto tangent. For us to be able to use the keyframing options on the channels that we want, it is possible to create channel groups with the Setup Groups button. When we activate the Setup Groups mode, we can see the Groups panel. First, let's create a new group, which we will name Lip Sync. And we click on New. In this group, we want to store all the channels related to the mouth positions, so we select them and click on the arrow pointing to the left. Now, using AutoKey mode, we'll shape the mouth to something like this. To make sure that the interpolation is the same on all the mouth-related channels during animation, we select the Lip Sync group and then we click on Create Keys. You can see that only the channels within the Lip Sync group are affected and receiving keyframes. By using the Setup Groups tool, we can create any group we need. For example, let's create another group called Eyebrows. We assign to it the appropriate channels. By using Create Keys on this group, we can create keyframes only for the eyebrows. Controlling different morph targets becomes much easier when we animate with Morph O matic and its grouping and keyframing tools. Here we have the global parameters rollout. Within it, we can recognize the 5 usual Diomatic plugin icons. We can use these to check, for example, the version installed, the authorization status, get access to the support site, or to the help file. In this section, we have the ability to control the maximum and minimum limits for all the channels. By default, there is no limit set. This allows us to set both positive or negative values for all the channels. By activating the Limits button, we'll limit the ranges permitted for all morph channels. We can, however, override these limits on a per channel basis. We'll go into that in detail later. The Use Selection and Original button allows us to have only certain vertices in the model being affected by the Morph-O-Matic modifier. For example, here we have a vertex selection. If we morph the model, the entire model is affected. By turning on Use Selection button, we can have the modifier deform only the selected vertices, including those in the sub-selection. We also have the ability to check the memory used by Morph-O-Matic. We can see that the morph targets currently use 2.8 megabytes of memory. Also, we can set the increment value for all Morph-O-Matic spinners. As you can see, all spinner values are incremented by 1 right now. We can set this to higher or smaller values. This button allows us to create a Morph-O-Matic material, which we'll see in more detail later. With this button, we can load several morph targets into memory. We can also reload them all at any point using the Reload All button, or set Morph-O-Matic to automatically update as needed. If we modify a morph target, Morph-O-Matic will update its channel accordingly. The Extract to Scene button allows us to extract morph targets back into the scene. This way, we can recover deleted morph targets. Morph-O-Matic can also automatically relink the extracted morph target to its according channel. We can also remove unused channels. In this example, we can see that there are 2 channels that are not being used, so we can remove them to save space in the channel list. This is the animator's preferred button, the Display Floater. This button will launch a resizable channel list floater with all the morph targets in the modifier. The size will depend on the display resolution. This panel allows us to work on morph animation even if the morphing object is deselected. We can also have several of these panels open at the same time for various characters. Here's the Setup Groups button, which we've seen previously. Lastly, we also have these buttons to save or load the Morph-O-Matic file, which includes all the animation and the modifier setup. Sometimes, when importing a model or morph target from other software, a problem can occur. When morphing, the model moves by itself from top to bottom or left to right. To fix this problem, we have access in Morph-O-Matic to the pivot subobject level. By default, it uses a value of -1. We can change the pivot to the vertex of our choice. All we need to do is select the vertex we want to use. It's suggested to use a vertex that does not move when morphing occurs, such as for example this one at the bottom of the neck. We can see that the problem has been solved. If we change the pivot value back to its default value of -1, the object starts moving again. By simply selecting a vertex that does not move, we can fix the problem of position shifting that we see sometimes when animating morph targets. We have here two morph targets loaded into Morph O. The first one is the eyebrow moving upwards. The second one moves the eyebrow downwards. If we add both morph targets, we get undesirable results, as you can see. Because of this, it is necessary for the animator to go from one to the other while passing through a value of 0 for both. With Morph O, we can assign several morph targets to the same channel. Let's select the second morph target for this channel. In channel parameters, we can see that there are several morph targets in the list. The color of the channel has also changed from a dull green to a brighter green. When the channel value is modified, we will go through the morph targets that are part of the list. There is no limit to the number of targets we can include. Let's set a value of -100 for one of the progressive targets. We cannot go below 0 because there is a global limit set. We will override it by specifying local limits for this channel that will go from -100 to 100. This way, if we go towards 100, the eyebrow rises, and towards -100, it lowers. An important thing is that the interpolation, if we follow a precise point, produced a beautiful curve, while by default, the majority of the morphing tools will give a more linear result that looks more rigid. Morph O contains a cubic system of interpolation which gives excellent results and a more realistic deformation style. We can now get rid of the other channel. By animating only one spinner, we will control the eyebrow in a very intuitive way. Another example of progressive morphing would be an eyelid. Thanks to several in-betweens, we can make the eyelid follow the sphere shape, as we can see here. This works for both the top and bottom eyelids. This deformation would be impossible to produce with a linear morph. Thanks to the cubic morph, the eyelid follows the spherical shape of the eye perfectly, due to the intermediate shapes included in the morphing. Here we have a feature only available with Morph O, the creation of view-dependent morph targets. We have here a character with a very large nose. The problem is, when he turns towards the camera to speak, we can't see his eyes. To solve this, we created a morph target with a lowered nose so we can see his eyes. It doesn't matter how nice the model looks in perspective view, because we will be seeing him from the front. As you can see, there is also some morph animation on the mouth. We will now add a morph target to this channel, which, instead of being a normal progressive morph, will be a view-dependent morph channel. First, let's turn on view-dependent by clicking on this button, and specify a camera axis, Y in this case. It is also necessary to specify which view will we use. In the camera list rollout, we select the camera to use. We now assign the morph targets just like we do with any other channel. Now, we'll set the morph target to have a full influence at an angle of 90 degrees. In the original morph positions, to become active at angles of 45 and 135 degrees respectively. From this point on, as you can see, The morph target is active and animated depending on the angle of the head relative to the selected camera. If, for some reason, we're not fully satisfied with the effect, we can reduce it using the weight parameter to have the model return to its original position. This parameter can be animated and adjusted at any time. This feature is very useful when we want, for example, to deform a character that has notorious deformations based on the viewing angle, such as traditional animation characters that are adapted to 3D. Morph O uses a very powerful file format, the MOM file format. We can save an MOM file and specify what we want to save with it. We can save each morph target's geometry to merge it into another scene. We can save all the current parameters, all animation, the global parameters, the group setups, and the markers we've created. In this case, we'll save everything but the geometry. Let's save our MOM file. If we decide to remove all the keyframes of the character and set all values to 0, we can see that the character moves, but without any facial animation. If we load the file we saved, all the channels are recognized automatically and appear in the list. We can still bind incoming to existing channels manually if desired. In this case, since the files have the same name, binding is performed automatically by name. We can choose to load the file at the current time, load the animation, the setup, the parameters, or the markers. After setting the appropriate selections, we click on the Load button. We can see that the animation was saved and loaded properly. This allows us to transfer precise information from one max scene to another, like the keyframes, the animation curves, and even the geometry of each morph target. We can animate a character in low resolution without an environment. This basically is the same idea as the BIP files in Character Studio, except that these are optimized for morphing animation in Morph O. Here we have two faces. The first one has Morph O applied, and the second one is a morph target. We can see the existing animation, which morphs the head onto a smile. The morph target has a texture applied that adds more pink color to the cheeks. We would like this texture to appear when the morph is occurring. We can do this by going into the channel's parameters and activating the Use Target Material option, which will allow us to use a target's material as the morph progresses. We first need to create a morphomatic material. If we go into the material editor, we can see that two materials are created. One for the original head, which has a gray diffuse color, and one for the morph target, which has a blue diffuse color, just for illustration purposes. After creating the morphomatic material, if we sample the material applied to the head, we can see the morphomatic material there, which has the original material inside. We can see the face changing from gray to blue as the animation progresses, and then back to gray. There is no way to see the map blending in the viewports, but if we render an image, we can see that the pink texture of the target is being applied to the original model based on the morph value for that channel. Morph O matic is able to manage a texture and geometry morphing at the same time. We could have a series of progressive morph targets, each one with its own material. For example, if we had a hand animation, we could have the tendons bump more when the fingers move, or veins that change appearance. This material is also useful in the case of a character that would carry out an extreme deformation which required many progressive intermediate morph targets. Integration between Morph O matic and Cluster O matic is very simple. We simply need to apply Cluster O matic over Morph O matic in the stack to be able to deform parts of the face not deformed by Morph O matic. In this example, we are using Morph O matic to deform parts of the face like the eyelid, the mouth, generate different gestures, etc. And then thanks to Cluster O matic, we can adjust the positions of the eyebrows as we wish. As you can see, we can freely combine both methods and get the best of both worlds. We can use Morph O matic to control the parts where predefined poses are important, and Cluster O matic where we need total control over groups of points without restriction. Here we have a face created in Facial Studio. Now we want to animate it, not in Facial Studio, but in a morphing modifier like Morpher or Morph O matic. First, we will create various poses representing the various phonemes or deformations that we want to export to the modifier. Let's create the first one, a smile. Let's create a second one. It is important to do this at different frames. Let's create some more. Here we have an example of a closed mouth. Now an open mouth. Once we're done, we make use of Facial Studio's Target Maker tool. Target Maker makes it possible to create morph targets and to choose whether to export these to either Morph O matic or Morpher. We will first define the neutral head, and then define the different targets we created. In this case, at the 5th frame, we have created a smile. We move on to the 10th frame, where we have an angry expression. And at the 15th frame, we have a closed mouth. and at the 20th frame, an open mouth. Once we're done, we simply click on Generate Targets, and we have a model that already has a morphing modifier applied and is ready for animation. As you can see, we can use Facial Studio to create morph targets that will be used to animate within any morphing system such as Morpher or Morph O matic. Here we have an example of a face on which we have applied Morph O matic with a series of morph targets. We will use the face's deformations made with morph targets in Morph O matic to control the teeth's position using the controller Link O matic available in Morph Toolkit. We apply the Link O matic controller to the teeth. We then bind the teeth to the head. The first step is to define the position points. We will create 2 of them that will generate an average that will be used as the teeth's pivot point. We will now define the points that the teeth will have to follow while rotating. Now, if the mouth opens, the teeth will follow automatically. As you can see, when the mouth opens as a result of being morphed, the teeth follow. We can also see them following properly when the jaw rotates without having to include them within the morph target. This example shows how to integrate Morph O matic with Morph Toolkit to generate facial animation for a character. Morph O matic is completely compatible with Voice O matic. Here, we have a head with different morph targets in Morph O matic. The head has different mouth positions predefined for lip syncing. We will now go to Voice O matic's display floater and choose a sound file. We now map the sounds in the sound file to the Morph O matic morph targets. It is necessary to choose a progressive track, which is where keyframes are stored for Morph O matic. We'll do the sound mapping setup for each morph target present in the Morph O matic modifier. Once we're done, we click on Process Lip Sync and Create Keys. We can now see the result of the lip sync entirely created with Morph O matic and Voice O matic. Both plugins work very well together for the creation of lip sync and facial animation.